Hello, everybody. Uh, I've decided to go on. The books are coming, I believe. I don't know if they've arrived, but I'll check with the bookstore tomorrow. Uh, the first, well, we talked about the application layer. We looked at HTTP and DNS. And those were enough to give you a feeling for what's available at the application layer, since you use it almost every day. Email, remember, is at the applications layer. Now, we're going down to the next layer. When we have a system that's running TCP/IP, the application layer prepares whatever it wants to send. The application layer at the sender. So if you're sending an email, you you use your client to create an email, and then you send it off. Now to you, it goes straight across to whoever receives it. But that's not the true way it goes. The client creates the message that it wants to send with the information about who's supposed to get it and all that good stuff. And then it sends it to the transport layer program that is at your sender, at your computer, your node on the internet, not actually your computer, your node on the internet system that you work, the network you're working on. So the transport layer gets something to send. Now it looks at it, it puts on a header, which we saw when we were looking at some of the protocols from Wireshark, and it sends it to wherever the destination is. Now that's what appears to happen. That's the virtual view of it. As far as the transport layer is concerned, it's communicating with the transport layer on the other side. But in reality, it too is just like the application layer. It's sending the information down to a lower layer that will take care of more details. But when we talk about the transport protocol, we're really talking about the transport on one side to the transport on the other side. We'll also mention the interfaces between the transport layer and what's above it and what's below. Now, you know there are two transport protocols, UDP and TCP. UDP is very easy. We saw the UDP in the DNS, and there's not too much more to say about that. But in general, there's a few questions before we get into talking about the UDPs and the TCPs, etc. There's the idea of multiplexing. When I send a message to HTTP on a computer somewhere else, where I watch something from an HTTP, I usually send that to a socket number. The transport protocols, the full address is the destination euro or IP plus the socket number at that IP. You can think of the socket number as just a mailbox, a location where everything for a particular user on that side or particular program is going to be waiting for somebody to send it something. The usual rule is that if you have an HTTP server, you put that server listening at socket 80. 80 is the well-known socket for HTTPs. Nobody says it has to be there, but if you plan to do anything else, you've got to notify the world that you're not taking HTTPs at 80. So when I send the message, I send down the message to send and the IP of who is going to get it from the application layer, say the email, to the transport layer. The transport layer sees HTTP and it knows it has to send it to socket 80. Now, that goes across. But what if 10 people are sending it to socket 80 from 10 different places? What's going to happen at the host, the place where the final destination is? Well, what happens is called demultiplexing. What it means is that the various messages there all have IPs, addresses for certain users on them. So the host that receives the messages figures out who on their system is supposed to get what message. Multiplexing happens on the other side, my side, a sender. It takes all the messages for one socket and sends them together. So we don't have to wait in line, essentially. Now, that just basically is saying we are using a socket on both sides, and many things come into the socket and many things go out of the socket, so that there's work involved in the transport layer in figuring out which message goes where. Now, the next thing, and this was also in the Wireshark homework, the three-way handshake. This is in TCP. TCP is the best of the transports. It is a real transport protocol because it actually tries to make things perfect. But to do that, it first has to establish sort of a connection between the person who wants something and the person who's going to give it to them. And that is done by what is called a three-way handshake. What that means is that my TCP sends a message to the other TCP. The other TCP acknowledges it, and then I acknowledge I got the acknowledgement. Now, these are done with messages called ACK and SYNC. SYNC is a synchronize, and it basically says get the two TCPs working together, get the numbers. What they really need to know is the sequence numbers that are going to be put on messages. When I send a message, it may be too large to go out all at once. It probably is. So what I do is I tell you what the sequence number of the first byte is. When you get that, you know what number you got. You put that away, and you acknowledge what you're expecting next. And you put a sequence number on your message coming back. And then I send the next sequence number, the message with a larger sequence number, and it better match what sequence number you're expecting. And we have to check back and forth. That way we know if we lost anything. After all, if I sent 4,096 bytes and I start it with a 1, the next thing I send you ought to be 4,097. And if you acknowledge, if you are waiting for 4,097, then you'll be quite happy that you got mine.